Hi everyone, welcome welcome to LNP Renewable System Engineers. Today we are going to see about the basics of FCUs. So as a building management system engineer, as a building automation control system engineer, what are the basics we should know about the FCUs? So now while entering into the topic, let's ask the 4 questions to ourselves. We will need to find the answer before the end of the session. First question is, so why should I know about the FCU? Okay, what is FCU? Fan coil unit. Okay, where can I see how it looks like? What are the things as a BMS or a BACS engineer or a technician I should know in the FCU? Now let's enter. So this is how the FCUs looks like. This is one of the design, mechanical design. So this is the fan coil unit and this is the electrical part of the fan coil unit. So the fan coil units, while supplying inside the building now, it should the air from the FCU should go through the ducts. This is how the ducts looks like. So normally everything is installed above the false ceiling. Apart from the supply in the return lines of the FHUs, VAVs and fan coil units also being installed over the ceiling. This is how it looks like. So as I told earlier, this is a fan coil unit. This is the electrical part of the FCUs, and this is a cooling coil supplying the return line of the cooling coils. So this is one of the sample typical FCU graphics. Okay, so this is a fan. So the fan can be operated in can be categorized into two different varieties. One is fixed speed and the next one is a variable speed. Fixed speed is low, medium, high, 3 speeds. Fan coil units will operate in 3 speeds: low, medium and high, normally like fans that we are using at the home. And the second one is a variable type. It is nothing but 2 to 10 volt. Okay, we give the command operating control command 2 volt, it will be operating at a low speed, and if you give the 12 volt, it will be operating at a full speed. Normally fan coil units are being used in the places where the temperature is uh, need to be maintained in a fixed way. Example, for the servers and all, server rooms, we used to go for the fan coil units. Okay, based on the thermostat will be there to maintain that set point temperature. The fans and the cooling coils will operate. In the cooling coils, this is the cooling coil. In the return line, cooling valve actuator is being installed. So in order to control the set point, so for example, if the temperature is uh, 25 degree and the room temperature the set point is 20 degree, 22 degree. Okay, in order to maintain that 22 degree, the valve actuator will open. Okay, will close in the most way, so that it will try to retain the cooling water inside this cooling coil, so that the whatever the air which passes through this cooling coil will get cooled. So this is how the system will work. As I told earlier, through the PLCs or through the DVCs, direct digital controllers, we can control it. So these are the different signals. So fan speed can be categorized as fan status can be categorized as a digital input signal, and the auto manual status of the DDC can be categorized as a digital input signal. And fan, we can operate in modulating mode, so it is an analog output signal. And even the return line valve actuators also can be operated in 2 to 10 volt. It is a modulating one, so it is analog output. And if there is any fault from the fan, so it is a fan fault, so it is a digital input signal. As I told earlier, through from thermostat, so we can monitor the space temperature. It is analog input signals. So these are the different other signals which we are getting from the control panels. Okay, emergency stop, temperature sensors. So EI refers to these are the acronyms. Okay, and also apart from it, temperature alarm get raised, and we can fix the schedules also. So these are the mechanical control panels, electrical control panels, MCCBs. All the hardware electrical signals from the FCUs will be wired here. So this is how it is installed in the ceiling. This is one of the example of the FCUs. So these are the diffusers. Once it is closed now, only this part we can see. Okay, and see, this is the cooling coil. This is a supply line, and this is the return line. In the return line, see, there is a valve actuator. So control the flow of the cooling coil, cooling water inside this cooling coil, these valve actuators are being used. So, and also apart from this fixed speed and modulating speed, we can categorize the FCUs with based on the heaters. FCUs without heater, FC with heater. So FCUs without heater are being used in the places where only cooling should happen. Okay, and the FCUs with heater can be used in the places, for example, in the rooms, in order to maintain the humidity, or during the winter season, cooling will be more. So in order to balance that, we will use heaters. Okay. So these are the different signals which is being categorized in the analog and digital type. So cooling coil control valve and the fan speed will come under the analog output, and the fan running status will be in the digital input. Room temperature through the communication RTU we will take. Okay, and if we categorize FCUs with the heaters, cooling coil valve and the fan speed will be analog output, and the fan running status will be digital input signal, and the thyristor control output. The thyristor here refers to the heater. So heater control output, that is 4 to 20 milliamps output, it will be an analog output, and the room temperature is a communication signal. Okay. So as I told earlier, there will be a set point. Okay, 23 degrees Celsius, for example I'm giving. In order to maintain the space temperature cooling set point, okay, so the FCUs will operate from 2 volt with the lowest speed. Okay, and with the 10 volt it will be operating in the full speed. Okay, so electric heater cooling valve and fan speed can be modulated via the PID loops. Okay, these are the different alarms which we can set for as a BMS engineer for the FCUs. If the fan fails to run through the current current transformers, we can take the signal current relay, and for if there is any high temperature, we can raise a high temperature cutout alarm. If there is any communication failure, we can go for the communication failure alarm. And normally from the field, in order to communicate with the servers, backnet routers will be used. If there is any communication failure in the backnet routers, we can raise alarms. And as I told earlier, if the temperature is not achieved, okay, then we can go for a temperature deviation alarms, and we can take the events at what time the FC is enabled and disabled, and what time heat is enabled and disabled. Those events also we can monitor. Thank you so much. If any inquiries related to FCUs, feel free to contact us. Thank you.